Assalamu alaikum. Today we will be covering your lab number 12, which is on EIGRP routing protocol. And as I stated in my RIP version routing protocol, that these routing protocols are actually dynamic routing protocol, जिसमें you surpass the initial stage of static routing, जहाँ पे you have to manually enter the details, whether if it's a link is down and everything, every detail has been manually entered. यहाँ पे क्या होता है, they are dynamic routing protocols and they are updated accordingly. You have to just configure these routing protocol initially, right? So they work, as I said previously, based upon there are a set of many protocols to dynamic routing protocols. Now you will listen to the name of OSPF, ISIS, right? Similarly, now they work on a mechanism which is link state, right? Similarly, there is another mechanism which is followed by BGP, EIGRP, and RIP, which is distance vector. Now, as I stated previously, link state is similar to that your protocol is actually collecting the data and it's forming a database in the form of a full network, and it maintains the data of your entire network, right? Which is first of all time consuming, right? And plus it kind of slows down the speed of your network, right? So the next option is of distance vector protocol, which is used by both RIP and EIGRP, and it just keep the information about the routes and the nearby hops. So it's kind of a signboard, right? It just informs you about the next possible router which you should go to, and that router can lead you to your specified destination by blah 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 or dash 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 routers, right? So it's kind of a signboard. For example, if you are going from one city to the other city, you can see the signboards in the form of routers table, and it will finally move you or toward your destination, right? So the difference, yes, it's a these are distance vector protocols and they use kind of signboard mechanism, and link state vector protocols use kind of map mechanism, right? So let's move toward your EIGRP protocol, which is basically enhanced interior gateway routing protocol, and it measures the metric in terms of advertised distance and feasible distance. Now you know कि हमने cover किया था in RIP protocol that metric is a way to measure, right, the distance. Now in RIP protocol it was actually hop count, but when you are moving toward EIGRP it's the feasible distance and the advertised distance. The difference between the two will be discussed in the coming slides, right? So it supports IP version 4 addresses, and it is faster, and it chooses the best possible and the shortest possible path among the multiple routers, right? So EIGRP has a kind of neighboring routing table and it exchange information with neighbors, right? And plus it send update messages only when a topology update is occurring, right? Other than that, only hello messages are sent, and it is unlike this periodic message sending is unlike the RIP protocol. वहाँ पे same message is being broadcasted continuously after every 30 seconds. इसमें क्या होता है? Changes are broadcasted when there is a topology change present in the network, whenever there are some new additions etc. तो वहाँ पे आपका message broadcast होता है, right? Other than that, they send very short and simple messages of, let's say, messages that those messages are actually called hello messages, right? So when this is a network and this side of any host want to communicate with this side of any system, तो EIGRP among all these three possible paths, again आपका ये है and ये है, इसमें से best possible path choose होगा, and router 1 will advertise that path to this sideway neighbor, right, or the host, right? So accordingly R2 is selected because this is the smallest path and it will be advertised to 192.168.0.0, right? So when two neighbor routers are becoming neighbors, so initially they when they want to build a relationship or a network or when they want to become neighbors, they start with exchanging their routing information, right, and their topology table. And in those topology table, the best route or the shortest possible routes are fed into, right. Again, जिस तरह आपका IRP में था, when a link is down, alternates are present and it can easily switch to those alternates. Now, as I said previously, वहाँ पे आपका था advertised distance and feasible distance, or it can also be said reported distance. Advertised distance को आप reported distance भी कह सकते हैं. Let's say this is your router and there are 3 neighboring routers, and it want to reach some host here, right. So it will ask from this neighboring router, right. So it will count the distance up to that specified host and it will inform this router, right. Now this router will add its own distance from this neighbor and make it feasible distance. Now this distance was reported distance or advertised distance जो इसने बताया था up to that specified destination, and this router added its own distance up to that router, and now this distance is feasible distance. So in terms the metric of EIGRP is in terms of these reported distance and feasible distances, and it works on bandwidth and delays, right, delay times, and it's different from the RIP protocol which uses hop count, right. So now this is the same procedure as this path was the shortest, so accordingly तीनों path से आपका feasible distance report होगा, right, यहाँ से भी and finally जब आपको इस router के पास आएगा, so the term will be in terms of feasible distance and your reported distance. Now if this is reporting a distance, now this one is the reported distance and when इसको add किया जाता है, so it becomes the feasible distance and the reported distance. Accordingly यहाँ पे आपका ये feasible distance है and ये onward जो आपकी destination तक जाता है वो आपका feasible, वो आपका हो जाएगा reported distance accordingly. Now the procedure of communication is somehow between two routers. When they initially build a connection, they start with a hello message. They check that whether their subnet mask is same or not, ठीक है. उसके बाद if there's some update in the network, they send an update message accordingly and the router replies with an egg message, right. Again इसी तरह if there's an update in this system, update message and an egg message, somehow इस तरह आपकी communication होगी. And if there's no update, then communication is in terms of small short messages of hello, right. So if a link is down, then the message sent is again changed and it's the query message. And if this router knows any other alternate path to that thing, that link जो down हो गया है, then it will reply with the option of alternate path, right. But if it doesn't know itself any alternate path, then it will again reply but telling the router that it doesn't know any other alternate path. Accordingly आपका router, both of the router will be updated that the link is temporarily down and we cannot communicate with that link somehow, right. So this is kind of the communication procedure in a general way, and when you actually enter the commands जिस तरह आपके protocol में था, you will configure the terminal and then router, the name of the protocol which you are using on your router, and then there is an autonomous system number. Now if you are enabling this protocol and on let's say these 3 routers, you are giving it a autonomous number 10, then let's say वहाँ पे आपके 4 और systems हैं and you change their autonomous number, so that would be a separate system or separate neighborhood, right. So you can define the neighborhood with this autonomous number, right. Anyhow, you can also use no auto summary command, like for this IP address it's a class less IP address, right, because I want these 3, let's say for my network and this one for my host side, so it's काइंड ऑफ दिस वर्जन एड्रेस, राइट। तो यहाँ पे बिकॉज जो आपके सिस्को पैकेट ट्रेसर, जो मोस्टली जो आपके सिस्टम्स होते हैं, दे पिक देम अप इन द फॉर्म ऑफ क्लास ए एड्रेसिंग और बी और सी एड्रेसिंग। इट मीन्स कि क्लास फुल एड्रेसिंग की टर्म्स में आपके एड्रेसेस अपडेट होते हैं या फेड होते हैं इन द राउटर। सो यू हैव टू disable this auto summary, and plus when you are routing a network address, when you are typing in a network address जो कि classless है, then you have to type the mask with it, right। यहाँ पे आप additional में एक mask add करेंगे, unless it will by itself pick it as 255.0.0.0 and इसको shift कर देगा toward host site, right। So what else, आपने राउटर जो प्रोटोकॉल है वो बताना है। यू हैव टू ऐड दिस कमांड इफ़ यू आर यूजिंग क्लासलेस राउटिंग एड्रेसेस, एंड प्लस देन यू विल डिफाइन योर नेटवर्क्स, राइट। जैसे कि राउटर नंबर 0 के साथ द नेटवर्क्स आर दिस वन एंड दिस वन, राइट। सिमिलरली फॉर दिस राउटर the networks are this one and this one. Similarly for this router, these 3 networks. When you add all these networks, finally you will just make them communicate with each other. And again, if a link is down, let's say this one, then this PC will choose the alternate path to reach this PC, okay। So let's compare the both protocols. Now RIP use a different algorithm and EIGRP use dual algorithm, plus RIP can be used for smaller organization and EIGRP is preferable for large organizations. It use hop count procedure up to maximum hop count of 15, जबकि आपका EIGRP can go up to 255. RIP protocol uses hop count as metric value, as I stated previously, but यहाँ पे EIGRP metric value is calculated by this formula, which is 255 into bandwidth plus delay, which is changed from RIP version. And as I stated previously, it has a specified value in terms of feasible distance and advertised distance. Now this one is less intelligent, but EIGRP is a more intelligent protocol. And in RIP, your router has routing table and topology table, but with EIGRP, your router has neighbor table, topology table and routing table 3, okay। So this is all about your protocol EIGRP. So this is the end of your theory part. Let's move toward your lab section.